Hey everybody, welcome to another Consport video. A student requested this one on simple probabilities, so I'm going to go through and do it. Let's see how it works. So over here on the left-hand side, I'm just going to have the Cami open, and I'll try to upload the Cami as well, so you guys have a written copy of how to do this stuff. So it says you flip a fair coin. This is just simple probability. You guys remember the formula for simple probability? So the formula for simple probability is just real simple. It's funny, simple. And that's going to be that the theoretical probability, so theoretical probability, which is simple probability, is just going to be equal to the number of favorable outcomes divided by the number of possible outcomes. So when you look at the sample space, which is basically the collection of all possible outcomes, so the thing you're looking at, the model, for example, you're going to basically say, all right, well, how many things could happen? And how many things of the particular event I'm looking for could happen. Those are called the favorable. And then you take the favorable things and you divide it by the possible things. That's it. So it's favorable outcomes divided by total possible outcomes. Total possible outcomes. All right, and so let's just apply that as we go through it. So in this case, number one, it says you flip a fair coin. What is the probability of heads? P parentheses heads means probability of heads. And it says if necessary, round your answer to two decimal places. Okay, fair enough. So in this case, we can ask ourselves, what are the two options when we flip a coin? So if it's a fair coin, you can either get heads or you can get tails, right? Those are the two options. So what's the chance of getting heads? The probability for getting heads is just going to be one of the two options, right? So there's the option you're looking for. We call that the favorable. Favorable is going to be heads. How many are there? There's one option, right? Heads. There's only one head on a coin, right? When you flip a coin, there's two sides, one of which is heads. And then how many sides are there in all, right? What are the total possibilities? Well, you could get heads or you could get tails, right? There are two possibilities. So the total outcomes are two, right? So there's one, the desirable outcome, heads, out of the two possibilities. So when you think about the chance of getting heads when you flip a coin, it's one out of the two sides, right? So it's 1/2. And it says round your answer to two decimal places. So I'm assuming they want you to have a decimal here. So 1 divided by 2 is going to be 0.5. That's 5/10, right? So that's your answer. So you're just going over here and you put 0.5, and there you go. Next one. The next problem here, let me move my little floating head up, but let me see if I can zoom in a little bit for you guys so we can see these a little bit clearer. There we go. All right, so this one says, Jake is going to call one person from his contacts at random. He has 30 contacts. 16 of those contacts are people he met at school. What is P, or probability? He'll call a person from school. So once again, just go over here. We'll do the workout. So he's going to call from this list of 30 contacts. So what are the total number of contacts, right? Well, that's going to be 30, right? Okay, cool. And then he says that 16 of those contacts are people he met at school. So that's the number of the people at school. So that's going to be equal to the probability of the people that he from school, right? So the probability that they're going to be from school is just going to be the 16 out of the 30, right? Because 16 of the people are from school out of the 30 that he has on this list. So favorable over possible. And so it's really just going to be 16 over 30, which is going to be 8 over 15, right? And if you want to make it a decimal, you would just do it on a calculator, 8 divided by 15. So you just go 8 divided by 15, and you get the answer of 0.53 repeating. So that's going to be 0.53 repeating. And it says round your answer to the nearest two decimal places. So if you have 0.533, repeating forever, and you round to the nearest two places, it's going to be 0.53, right? Because when you look at the second place, right, you're going to say, oh, that 3 is going to round down. So it's going to stay at 0.53. So there's the answer, 0.53. 0.53. That's it. It's really that easy. It's just the number of favorable over the number of possible. So let's do the next one. It says Joel has an MP3 player called Jumble. The Jumble randomly selects a song for the user to listen to. Joel's Jumble has 2 classic songs, 13 rock songs, and 5 rap songs on it. So the first thing you guys want to do is you want to write down in this problem what's the sample space. So the sample space is a fancy way of saying the collection of all possible outcomes. So all the stuff that's on his MP3 player. So basically the sample space is all the stuff that's on the MP3 player, right? And what does it say is on this MP3 player? It says that he has 2 classic songs. So there's 2 classical songs. And it says that he has 13 rock songs. There's 13 rock songs. And then he has 5 rap songs. And that's all he has on this MP3 player. So it's going to randomly choose from one of these items, right? So you got to figure out what's the total possibilities. Well, what's the total? If we add all this together, we get 15 plus 5 or 20. So he's got 20 songs on his MP3 player. So randomly going to pick one of these 20 songs, right? Every time he hits play. Okay, cool. It says, what's the probability that it's a rock song or a rap song? Okay, so it says probability that it's a rock song or a rap song. Now that word "or" is something that you have to pay attention to. Or means add in probability, really. So this is the probability of a rock song plus the probability of a rap song. That's basically what we're talking about. Because both of these are now what we call favorable, right? So it's going to be favorable over possible. So let me just kind of indicate that. So it's favorable outcomes over the total possible outcomes, over the total possible outcomes, total outcomes. So in this case, if we want either the rock song or the rap songs, then those are both what we call favorable. So that means that all of this is favorable. What's 13 plus 5? 18. Okay, so you're going to basically say that 18 of the options are things that you want. And so 18 out of what? 18 out of 20, which is the same as times top and bottom by 5, 90 out of 100. Okay, which is the same as 9/10, which is the same as 0.9. So the correct answer is that there's a 90% simple probability that you're going to get a song you like. The only thing you don't want are the classical songs, right? And that's 2 out of 20 or 10%. So 90% of it is what you want. So you're going to put 0.9. And that's your answer. So the idea of or is that either of those two things are favorable. So you just take the probability of rock song and add it to the probability of rap story. So rock song would be 13 out of 20. Rap song would be 5 out of 20. So it's really 13 20ths plus 5 20ths, which is 18 20ths. Hence, 90%. Okay? Or means add, basically. All right, let's do the next one. It says you roll a 6-sided die. Okay, a 6-sided die. So on a 6-sided dice, let's go over here. On a 6-sided dice, there are 6 possibilities, right? So what is the sample space on a 6-sided dice? So on a 6-sided dice, or a fair dice, as he calls it, fair dice, you're going to see outcomes that are 1, 2, 3, 4, 5, or 6, right? These are your outcomes. So it says, what is the probability of rolling less than 4? So something that is less than 4. Okay, well, something less than 4. That's what we're looking at as our favorable outcomes, right? So our favorable outcomes are going to be the things that are less than 4. Well, looking at our dice, how many things are less than 4? Oh, 1 is less than 4, 2 is less than 4, 3 is less than 4. Is 4 less than 4? No, 4 is equal to 4. So that means that there are 3 things that are less than 4. Those are what we call, in this case, the favorable, right? Things we're looking for. So that's going to be 3. There's 3 of those things. And then what are the total things that could happen? There's 1, 2, 3, 4, 5, 6 sides on a 6-sided dice. So really, the simple probability here would be 3 out of 6, which is the same as 1 out of 2, which is the same as 5/10, right? So I think you guys all know that. Let me just kind of fix that, clean it up. So this is going to be 0.5. And then the next one says, Bruce is going to call one person from his contacts at random. He has 25 contacts, 25 total contacts. 20 of those contacts are from his neighborhood. It says, what is the probability to call a person not from his neighborhood? All right, so this is interesting. So in this case, you've got Bruce has got 25 contacts, right? So the sample space here is his contacts list. So it's his contacts list. Okay, so I can write this a little bit nicer. It's a bit sloppy right now. Let me try again. Sample space. There we go. And we have the sample space in this case being his contact list. And we know there are a total of 25 contacts. We also know that 20 of those are from his neighborhood, right? So those are from his neighborhood, right? From his neighborhood. All right. And so these are the things we know from the story problem. They're asking us what is the probability that he's going to pick a contact that's not from his neighborhood, right? Not from his neighborhood. Well, let's think about this. We can think logically, right? If there are 25 total and 20 are from his neighborhood, how many of them are not from his neighborhood? That would be your favorable, right? So in this case, the favorable is going to be the remaining 5 people, right? So out of his 25 contacts, only 5 of them are not from his neighborhood. So it would be the favorable 5 over 25, right? And then we can simplify that, times top and bottom by 4, and you get 20 over 100, which is the same as 0.2 or 2/10. So that's it. All you got to do is, in this case, think about, all right, if 20 are from his neighborhood, how many are not from his neighborhood? Well, the 25 take away the 20, right? I mean, I can write that out for you if you guys want, right? And so this is the idea of the whole minus one part equals the other, basically, right? Complementary pieces. So if you have the probability of not from his neighborhood, that's just going to be the 20, right? Subtracted from the 25. So 25 minus 20 equals 5. And that's going to be the total minus the part from his neighborhood, right? So that's his neighbors, right? His neighborhood. And then you're going to get the part that is not from his neighborhood. Not from his neighborhood. Okay, and that's it. That's kind of where that 5 comes from. So there's 5 outcomes that are not from his neighborhood. So the answer here, like I said, is 0.2. Let's go to the next one. Oh, okay, they got lots of balls here, different colors, circles, and stuff. Let's do that. Now, before I do that, I got to kind of add a page here. So let me add a page. And when we add that page, we can see a little bit clearer. I'm going to zoom into a little bit. It's easier for me to write when I zoom in here. So let me zoom in a little bit. Okay. And so it says, what is the probability to draw a blue or red marble? Okay, so there's a whole bunch of marbles here, right? So this is what we call the sample space, the collection of all this stuff. So this is number of what, 5? Is number 5? I think it's number 5. I think it's number 5. Let's zoom out a little bit so you can see. There we go. Is this the 5th question? 6th question. Okay, cool. So we're going to do this one here. So this is number 6. And we have to just literally count how many of these circles there are. So draw, count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. It looks to me like there's 21 because there's like this one that's behind here, and one that's behind here, and one that's behind here. So I don't know if you can move these pieces, but it's a little bit wonky the way that they've done this because it's like hard to see. Let me see if there's numbers here. Oh, there's like they give us the details there, right there. Perfect. So since it was hard to see, I was looking for more information. And so let's just look at what they give us. They give us a bunch of stuff. Great. So we have the sample space provided for us. List out what the sample space is. That's a collection of total outcomes, or all possible outcomes. And it says you randomly draw a marble from a bag of marbles that contains 8 blue marbles, 5 green marbles, and 8 red marbles. So it's a bunch of marbles, right? So it's a bag of marbles. That's the sample space. So you're going to analyze the sample space. What do we know? There are 8 blue marbles, there are 5 green marbles, and there are 8 red marbles. Now, when I was looking visually at it, I thought it was 21. Is it? 16 plus 5 is 21. Yeah, there are 21 total marbles. Okay, awesome. It says, what is the probability of drawing a blue or red? Okay, remember, or means add. So we're going to say probability of drawing a blue or a red means that the favorable outcomes are going to be blue or red, right? So these are the favorable outcomes, either blue or red, and or just means add. You're going to add those together. So I'm looking at this and I can see that I've got 8 blue and I've got 8 red. So together, how many blue or red do I have? And that'll be 16. So the answer is going to be 16 out of the total, which is 21. So it's just going to be 16 21st. Now 16 over 21, what's that really worth? You can just do that on the calculator. 16 divided by 21. So 16 divided by 21 is equal to, and that's, wow, okay, that's 0.0476 and so on and so forth. So if you write that out, that's going to be 0.0476, and then it's like, dot, dot, dot. And he said that you can round it to the nearest second decimal place, right? So that would be rounding to right there. And so that's going to be 0.05 approximately. So approximately 0.05, because that 7 is going to make the 4 go up 1. So if you were to use a decimal answer, then you would put 0.05. And it's funny, it says not quite right, not quite yet. Okay, so that's interesting. Can I put in the actual answer? Let's see if I can put the answer in. It says blue or red marble, so I would think it would be 16 out of 21. Can I put that in? Well, then why does it say, if necessary, round your answer to 2 decimal places? So they don't want you to round it 2 decimal places, right? Silly. And yeah, that's kind of funny. That's pretty funny, actually. Well, now I can see how you guys get annoyed at cons sometimes, but let's move on. That's how it works. Let's do the next one. All right, so this one is you roll a fair 6-sided die. So the sample space is a fair 6-sided dice. So let's do that one. So our sample space in this case is a fair 6-sided dice. You always want to list out the sample space. So that's a fair dice, fair 6-sided dice. And so that means that your outcomes that are possible here are going to be 1, 2, 3, 4, 5, or 6, right? These are your outcomes that are possible. And it says, what is the probability of rolling a 2? So this is really simple. It's just, what's the probability of getting a 2? Well, 2 is your favorable, right? So how many 2s are there? There is only 1 2. So that means that the favorable is 1. And how many possibilities are there? There are 6. So you would just say 1 out of 6. And that's the answer. And since I don't have to put it in decimal form, why would I? It's 1/6, 1/6. I don't know why they even told you to round it 2 decimal places. There's no reason to do that. All right, and that's how you do the problems.